Welcome to qnawire.
Okay. We had a sample of hydrogen, which was found to contain 49 grams of nitrogen to 7 grams of hydrogen. We can figure out what the ratio of nitrogen to hydrogen is by mass. And if we know what the ratio is by mass, by invoking the molecular weights of nitrogen and hydrogen, we can figure out what the molar ratios are, right? So the first step to doing this is to divide each of these masses by the lowest mass that we have. So we would divide each by 7 grams. And when we're done, what we'll be left with is the relative ratio of these by mass to each other. So we end up with 7 nitrogen, 1 hydrogen. And what this tells us is that the ratio of nitrogen to hydrogen is 7 to 1 by mass. Okay, and if we want to figure out what the ratio of nitrogen to hydrogen is by mole, which will allow us to give the molecular empirical formula, we just need to divide each of these numbers by that particular element's molecular weight. That is, for nitrogen, we take 7 nitrogen and divide it by 14. For hydrogen, we take 1 hydrogen and divide it by 1. Those are roughly the molecular weights. And what we end up with is 1/2 nitrogen to 1 hydrogen, and this is the molar ratio. The ratio of nitrogen to hydrogen by mole is 1/2 to 1. And what makes this in probably standard form, I would need to multiply this whole thing by 2. Usually we have whole numbers when we do ratios, so we'd say or 2 to 1, right? Sorry, 1 to 2. 1 to 2, right? Because we multiply this by 2 and multiply this by 2, and we get 1 to 2, which means that there's 2 hydrogens for every nitrogen. So the empirical formula, therefore, is nitrogen 1, hydrogen 2, or NH2. That is the empirical formula of hydrazine. Okay, now we're told that the molecular weight of hydrazine is 32 grams per mole. So what's the molecular formula? Well, let's figure out what the unit weight for each empirical formula unit is, right? So a single empirical formula unit of hydrazine is 14 plus 2 times 1, right? The 14 is from the nitrogen, and the 2 times 1 is from the 2 hydrogens. And we get 16. Now we figure out how many empirical formula units we need to get the molecular formula. So we can take 32, oops, not 13, 32 divided by 16 equals 2. So we know there's 2 empirical formula units in each molecule, or we can say that we have N2H4 as our molecular formula. We simply multiplied each of our components by 2. Okay, so now we have the molecular formula of hydrazine. Finally, we need to draw a Lewis structure, assuming there is a single nitrogen-nitrogen bond in the middle. The other thing we should know right off the bat is that these hydrogens have to be terminal, right? Hydrogens can't ever be bridging. You'll never have a bond to a hydrogen and then a bond coming from it. They're always on the end. The reason for that is that their valence shell only wants to see 2 electrons, so they can only ever have 1 bond and no lone pairs. Okay. Does this seem right? Well, we know these nitrogens don't have a full octet, so let's step through the process of figuring out Lewis structures. Remember, nitrogens each bring 5 electrons to the party because they are in group 5A. So we can say 2 times, so due to the nitrogen, we get 2 times 5 equals 10. And due to the 4 hydrogens, we get 4 times 1 equals 4 electrons. So in total, we should expect to have 14 electrons in our structure, and currently we've got 2, 4, 6, 8, 10. We need to, basically we need to add four more electrons. Because we know there's only a single bond between the nitrogens, the only way we can really add those is to add a lone pair to each nitrogen. And that's good because we know that when nitrogen has 3 bonds in a lone pair, it's neutral. And when we draw Lewis structures, we'd like to minimize the formal charge of any of the atoms. So this is the Lewis structure of hydrazine.